Okay, so the last part are broken into two parts, the vertical line test and something called increasing, decreasing stuff. Um, the vertical line test is pretty straightforward. Um, it's basically saying if you're given a graph, how can you tell if it's a function or not? And it's pretty straightforward. We're going to test using a vertical line. So the vertical line says is if every vertical line can be made only intersects the graph at one point and precisely at just one point, then it's a function. However, if any vertical line that touches the graph more than one point is not a graph of a function. Okay? And these are pretty straightforward. So let's suppose we have this graph here. Okay? So let's suppose this is our graph here. Okay? And we want to see, using our vertical line test, is this a function or not? Okay? So I'm just going to make a vertical line. So remember, vertical is just going this way. Oh, vertical line. This is horizontal. Vertical line test.
It's up and down.
Yeah, this is not right. This is very wrong. This is horizontal. What was I thinking? Was it high or something? I don't know what the hell was I talking about. Horizontal line test. Yeah. Wow. What the heck was that about? For horizontal. So if you make a horizontal line, you want to see if it touches the line at least once. So I'm just going to make a line like that. And now I'm just going to pick. Okay. So it touches the line here, there, 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 and there. So that is more than one. Now the thing is, sometimes you can say, well, what if I pick it here? Well, here it only touches it once. So yes, it is true, right? But the thing is, every horizontal line must do it. So these are all horizontal. Every horizontal line must touch it. So it just be not one specific, but anything I want. So I can make infinite number of horizontal lines. And if at least one doesn't work, it fails. So therefore, this one is not a function. Okay? And it's that simple when it comes to it. So let's just try another example. So these of example, just a line itself. So this is an example of I could pick any horizontal line, right? I just keep going, keep going, keep going. And then you notice no matter what horizontal line I choose, it's only going to touch it one time. So therefore, this is yes, right? This is a graph of a function because it passes that point. That's it. Pretty straightforward, right? That's all it is. Definitely want this on the test, right? All the tests should be like this. Okay? So you're just going to have like two questions on homework, but it's just a simple example illustrating that when it comes to it. Okay? What the main focus at the end of this, what I want to talk about is the main part here, increasing, decreasing, and constant, because these are pretty major parts when it comes to mathematics itself and higher math as well. So what we mean by increasing, decreasing, and constant is the best way I can think about it is just give you a quick little example of what I mean by that. So let's suppose we have like this here. And it's general. We don't have like numbers, but it's just like a general graph like this. So try your best to kind of mimic that. Now, all we want to do is identify when is it increasing, when is it decreasing, and when is it constant. Okay. So increasing means like, a roller coaster, you're going uphill. Decreasing means you're going downhill, right? You're going down. And constant means you're flat line, right? No one wants to be flat line. That means you're D, right? When it comes to it. So all we're going to do is check. So, and you always go from right to left, just like we read. So again, so left from left to right. So starting from here, going that way, we want to identify where is it going in each individual case. Again, always going that way, just like we read in English. Okay, so going here, so we're going up. So therefore, from this portion, this is increasing, right? So it's increasing from here all the way to there. And then at this marker to that marker, it is flat. Well, flat means constant. Right, so it's not going anywhere, it's just a flat line. And then from here to this point, it goes up again. So it is increasing. And then finally from here to the rest of it, it is going down, or, roller coaster going down. So it's just decreasing. And that's pretty much it when it comes to it. All we want to do is now identify when is it going in those three specific ways. And the way we're going to do this is write it in interval notation. That's hence the reason why we big emphasis on writing stuff on interval notation. From where to where is it increasing? From where to where is it decreasing? And again, from where to where is it constant on the graph itself? Okay. Now, so like I said before, when it came to functions, right? Was it for domain and range? I believe I said that for domain range. Domain and range. Yeah, here. So remember, like I said earlier, where the higher the math, the more complicated the definition becomes, but it's basically layman's terms, that's what it means. Same thing applies here, okay? So I'm going to give you some very, very complicated definition, but it literally means exactly that. Where is it going up? Where is it flat? Where is it going down, okay? And that correlates to right here on the next page. Okay. Suppose that a function f is defined on an open interval a to b, and x1, x2 are in a and b. So again, basically what this is saying right here is, let's suppose I have a graph that goes from a all the way to b. So for example, let's suppose here, this is my a and b. So this is my a and this is my b. So I have some interval that goes from a all the way to b right here. And there's some x values in between. That's pretty much what that says, okay? So if we then have this scenario, therefore, the actual definition of increasing is x1 is less than x2, therefore, the y values are less to each other. So again, in layman's terms, you're just going up, going up. Same thing, we're decreasing over the interval a and b. It's decreasing when x1 is less than x2, therefore the y values are actually flipped, or less than. Again, means just decreasing. And then lastly, it's constant, again, when x1 is less than x2, but the y values are equal to each other. So in other words, where is it flatlined? Okay. That's basically, in layman's terms, what that means. Again, this is a little bit more advanced terminology, but that's what that means. Just know where that is itself, okay? I will never ask you to write it like this. Nowhere in math will they ask you to write it like this unless you do like proofs. That's really, really higher math. They'll always give you a graph of some sort and just ask you where is it increasing, decreasing, and so forth. And that's how it's going to be in this class. I will give you some graph and you're just going to write it out. And you'll see in a nice example in a little bit how that's going to work. Okay. All right. So any questions there at all? All good? Okay. So let's actually do an example you would see. Let's say, for instance, for your quiz, right? When it comes to that. try your best to mimic what we have here. All right, so remember, we want to write this in interval notation. So remember, when it comes to interval notation, we have a start and an end point, right? Now, when it comes to our interval notation, the numbers we're looking for is always going to be the x values, never the y values. So whenever it asks you to find from where to where is increasing, it's always from one x value to the other x value. Never going to be up and down. It's always from left to right, only on the x scale, which is pretty nice because we're only looking from where to where is it going up, where to where is it going down, okay, when it comes to it. Now, what I always like to do is just like we did on the other one, is try to mark where the changes are in the graph, right? With a little marker here and there. So, for example, here, so we go down here, and eventually at this point, it changes direction, right? So we know this is going to be a special case here. Looks like here's also a special case right there because it's going up and then flattens. Here's an also change, and there is an also change. Right, so we have a total of 1, 2, 3, 4 different changes in this graph itself. Okay. All right, so again, from left to right, let's see what's happening. So from here to here, we're going down, so that's decreasing. So first we're going to do for decreasing, so let's do a decreasing interval. And remember, from what x value to what x value are we decreasing? So we start from here, which is -1, -2, -3, -4, -5, -6. And then to what x value do we stop decreasing? So we know we marked it here, so this is going to be approximately there. So from -6 all the way to this x value, which is -1, -2, -3, it's decreasing. Remember, we're not looking at the y's. It's always on the x scale. So we know from -6 to -3, it is strictly decreasing. So again, any questions on how we got the interval? Okay, and let's keep going. So from this marker to here, it is going up, so it is increasing. So again, we're starting from -3, that's where we started going up, all the way up to, again, on the x scale, stops here, so that's 0. We strictly increase. So notice the overlap, right? Because we're just following the exact same template. All right, from here to here, it is constant, right? It's just a flat line. So now we go to constant. So from the x value, which is 0, all the way to the x value of 1, 2, 3, it is just a flat line. Okay, and now from here to here, we go up, so that is increasing. So we have some more increasing. So we have another interval of increasing. So we start from 3, and we go all the way up to, again, the x value of, so this is 3, all the way to 3, 4, 5. So from 3 to 5, it is increasing. Again, we don't care about how high it goes. We just care about the x values themselves. And then lastly, from there to there, it is decreasing. So we have another decreasing interval. So again, always the x, right? So we go down here. This is 5, 6, 7. This is the 8. So again, I don't care about this way. I just care about the x. So from 5 all the way to 8, it is decreasing. And there are our answers here.